Hello and welcome to our group presentation. For this group 10 demonstration, we will demonstrate on question 3, which is question 3a is we need to calculate the general solution for the homogeneous system of first order differential equations, which given the equation is y1 prime is equal to 6y1 plus y2 and y2 prime equals to by 5y1 plus 2y2. Next, on question number 3b, we need to find the differential equation but with added of 4 exponent 7x and 10 exponent 7x. The equation is given as below. Also, we need to calculate the particular integral yp using method of undetermined coefficients. And finally, we need to solve the particular solution of the system if initial condition is applied, which is y when x equal to 0 is 2 and 1. So let's not wasting any more time, I will just proceed with question number 3a. First, we need to register y prime equals to ay. Next, we need to input the a value, which is 6, 1, 5, and 2. Next, we use matrix identity. So we got 6 minus by lambda, 1, 5, 2 minus by lambda equal to 0. And we use the formula AD minus BC to get the lambda value. So AD minus BC, we got 6 minus by L times with 2 minus by L minus 5 times by 1 equals to 0. So if we simplify the equation, we get lambda square minus 8 to lambda plus 7 equals to 0. So when we solve the equation, we get lambda 1 equals to 7, meanwhile lambda 2 is equal to 1. Next, we input the formula of matrices, which is 6 minus lambda, but for lambda equal to 7, we just input the lambda equal to 7. So 6 minus 7, 1, 5, 2 minus 7, matrix xy equals to matrix 0, 0. So we got x, negative of x plus y equal to 0 and 5x times 5y equal to 0 as well. So let's x equal to s, so y equal to s is the same because 5x times 5 plus 5y. So when we put the x on the other side, we got the same. So v1 is 1, 1 to the s. So for lambda equals to 1, same, 6 minus by lambda, but the lambda is 1, so we input the lambda is 1. So we get 6 minus 1, 1, 5, and 2 minus 1, 2 matrices xy, 2 matrices of 0, 0. So we got the equation of 5x plus y equal to 0 and 5x plus y equal to 0. So let x equal to s. So we get y is equal to negative 5s. So v1 is 1 and negative 5 to the s. So we use the same formula, which is AD minus by BC. We get 1 times by minus 5 minus by 1 times by 1. We know 1 times 1 is 1, so we just gonna ignore the 1. We just input the 1 at that. So we got minus 6. So the general solution is yx equals to A matrices 1, 1 exponent 7x plus B matrices 1 negative 5 exponent x. So this is the final solution of the question 3a. Let's continue to question 3b. So we know that there are two equations that are added to our equation from question 3a. So we need to declare G is equals to 4, matrices of 4 and 10 of exponent 7x. So the equation is y prime equals to ay plus g. We just input the a values and the g values as stated below. Next, we need to obtain ycx. Ycx is the same as final solution from question 3a. So we're just gonna input it there. So A matrices 1, 1 exponent 7x plus B matrices 1 negative 5 exponent x. So since ycx is equals to g, we have to multiply the yp by x. So assume yp is matrices of cd exponent of 7x. So since yp is equal to yc, we need to find the YP new. YP new is matrices of C, D, X, E, 7X plus matrices E, F, E, 7X. So notice that YP is not the same as YC, so we're good to go. Next thing, we need to find the YP prime of the YP new. So YP prime is matrices of CD exponent 7x plus 7 matrices EF exponent 7x plus 7 matrices CD x exponent 7x. So when we rearrange the exponential form factor, we get YP primes is equal to matrices of C plus 7E, D plus 7F of exponent 7x plus 7 matrices of CD x exponent 7x. Next, substitute the YP prime and YP into the Y equals to AY plus V equation. We got the equation as down below. You can read. So, we need to apply by equating coefficients. So, x exponent 7x is 7c, 7d, matrices 7c, 7d equals to matrices 6c plus d, 5c plus 2d. So we got equation 1, c is equal to d. So move to exponent 7x, we got c plus 7e minus 6e minus f equals to 4. So we got c is equal to negative e plus f plus 4. So we input that in equation 2. Next, we also get the d plus 5 minus by 5e equals to 10. So we're going to input that in equation 3. So we substitute 1 into 3, we got c equal to 5e minus 5f plus 10. So that is equation 4. Compare equation 2 and equation 4, we got negative e plus f equals to 1. So let e equals to 0, we got f equals to 1. So substitute the e and f value in equation 4, we got c equals to 5. Substitute the c value in equation 1, we got d equals to 5 because c is equal to d, so when c is 5, d is also 5. Next, we input all the information into the YP. So YP is 5x plus 0, matrices of 5x plus 0, 5x plus 1, 2 exponent 7x. So this is the general solution as you can see the down below. So you guys can read. Next, we need to calculate the particular solution when x equal to 0 is 2 and 1. So the equation is down below, you guys can read. So we got equation 1, which is a plus b equals to 2, and equation 2, a minus 5b equals to 0. So we just use calculator to calculate the value of a's and the value of b's. So we got a is equal to 5/3 and b is equal to 1/3. So the particular solution for this question is 5/3 to the matrices of 1, 1 exponent 7x plus 1/3 to the matrices of 1, negative 5 of exponent x plus by matrices 5x, 5x plus 1 to the exponent 7x. So that's all for the manual calculation. Let's proceed for the MATLAB calculation.
Okay, now I will proceed with the calculation of chapter 3, which is the question 3. So just now I already showed to you all about the manual calculation and on how to find the solution of the question. So now I will demonstrate to you all about the MATLAB code on finding the same answer as the manual calculation. So first we need to declare sims y1 x and y2x. Then we need to declare also ODE1 is equal to differentiation of y1 equal. We need to put two equals there. So 6 times by y1, 6 times by y1 addition with 1 times by y2. So we need to put semicolon here. As well as we need to declare also ODE2. So ODE2 is differentiation of y2 we need to put 2 equal as well, and then 5 times by y1 plus by 2 times y2. Next, we need to insert all the ODE1 and ODE2 into the formula ODES equals to ODE1 semicolon ODE2 and then semicolon. Next, we need to use function dsolve on the bracket ODES, same as the top, semicolon. Don't forget to put semicolon. And then we need to name it. So I want to name it as solution y1x equals by y1, and then next solution of y2x is equal to y2. So the MATLAB will execute the calculation. So we need to display the output, which is the solution. So solution of y1 x. Okay, semicolon, as well as solution 2. Solution of y2 in the bracket x, semicolon. Okay, notice at this dsolve in the bracket ODES, we need to put the name in front. So I will put z is equals, and then we need to put in here also z dot y1 and then z dot y2. So in this case, the MATLAB will perform the equation as it should. So we need to execute this code. Click run, and then it will ask for name. So I will name it as question 3 ODE group project. Then I will save it in ODE project. Okay, click add to path, and then we need to open the command window. Okay, this is our command window. So I will zoom or cannot zoom. Okay, so y1 is equal to c2 times by exponent 7x minus by c1 times by exponent x over 5, and y2 is c1 times by exponent x plus by c2 times exponent 7x. So notice that the c2 is our a and the c1 is our b. So if we take a look at the manual calculation, it is the same as the MATLAB calculation. It is different at the constant name. In manual, we use A and B, but in MATLAB, by default, it use C1 and C2. So as long as the exponent power is correct according to their constant value, so it is correct.
Okay, now let's move on to question 3b. So as always, seems y1x and y2x must be included there. So we need to declare a matrix function of y, which is y is equal to y1 semicolon y2, and then we need to declare also ODE1 and ODE2 function, which is the differentiation of y1 equals to 6 times by y1 plus 1 times by y2 in addition, plus 4 times by exponent 7x. So same as ODE2, differentiation of y2 equals to 5 times by y1 plus 2 times by y2, and addition of plus 10 times by exponents of 7x. As the same as question 3a, we need to declare the ODES, which is the matrix function of ODE1 semicolon ODE2. Then we need to put the initial condition, which is c is equal to y when x is equal to 0 is 2 and 1. So we need to put the solution y1 underscore solution x y2 underscore solution x equals to dissolve or the esc. So the MATLAB will execute the function to get the exact final value, same as the calculations. So when we input this, so I will press enter, and then the system already registered into MATLAB, so we need to display it. So first we need to display the y1 underscore solution x. Don't forget to put the bracket and semicolon. Okay, so this is the answer for y1. Next, I will execute display function to display y2 solutions. Don't forget the semicolon. Okay, so this is the y1 solution and the y2 solution of our calculations. But notice that in MATLAB, they are not same as the calculation, manual calculation, because it's compute by the computer, not by a human using formulas. They got their own formulas, so we need to simplify it. So I will execute simplify of y1. So this is y1 simplified. Then I will simplify also the y2 solutions. Press enter, and then this is the y2 solutions. So notice that the final answer is now almost the same as the manual calculations, just the matter of the arrangements, but it is the same as manual calculation. So it is proof that the manual calculation and computerized calculation, which is by MATLAB, is the same. So you get the answer. So I think that's all from our group. Thank you very much.